Su-27 aircraft. The general conception of the fourth-generation jet fighter was expected to use medium swept wing with a low wing loading. This was a way to improve maneuvering and takeoff and landing performance. So did the compromise aircraft high speed to its high maneuverability? Of course not. New generation engines allowed to achieve double the speed of sound even with such a wing. This was a completely new approach to aerodynamics research, significant progress in engine building, a new fighter control system. Almost every field of aviation had its breakthrough. However, we are a bit ahead of time. Tactical specification requirement on advanced frontline fighter was issued in 1971. The tender to develop a new fighter was shared between 3 design bureaus. These were Yakovlev, Mikoyan, and Sukhoi design bureaus. Till now, we were considering a fighter primarily as a flying vehicle. A fighter must definitely have a good flight performance, but this is obviously not enough. In order to become a superior combat system, a fighter needs up-to-date onboard equipment, armament, and many other things. It was a fighter updating where Pavel Sukhoi saw some problems. The general designer doubted that the Soviet electronics industry could provide up-to-date equipment for a new fighter. At that time, Soviet electronic equipment was quite heavy and big. The heavier electronic equipment is the heavier an aircraft is. In such a situation, to achieve required flight performance was far more difficult. It was also known that the American new generation fighter was already under development. The Soviet Union was behind the States in this race. It was necessary to design a fighter with the characteristic different from an American rival, so that it would be superior to enemy aircraft. It was that time that such a specific term as air superiority fighter appeared. A bench for two-fighter aerial combat was built for that purpose at our institute. The bench comprised 2 moving cockpits with all 3 degrees of freedom, though it was kind of conventional. However, the horizon was rolling and turning depending on all aircraft maneuvers and emergence of an enemy aircraft. According to the specification requirement issued by the militaries, the Soviet fighter characteristics had to be 10–15% higher than those of a new American fighter. It was also pointed out that to increase combat survivability of the new Soviet fighter, it had to be a 2-engine aircraft. At that time, the Soviet Air Force Commander-in-Chief was Marshal Kutakhov, and his deputy in weaponry was Colonel General Mishuk. Mr. Mishuk was a very experienced aircraft engineer. He served in the Army during World War II and was an educated and competent officer. Marshal Kutakhov was a combat pilot, here of the Soviet Union. He was always interested in technical aspects. He regularly attended meetings at the Ministry of Aviation Industry. He also visited the Institute very often to meet with our general designers. I remember he used to call us once a month and asked, "Well, science man, have you got any news?" The military people treated us very well. They had a big stake in the fourth-generation fighter concept. In those times, a lot of money was spent on aviation projects. The country leaders, headed by Leonid Brezhnev, spared no expense on aircraft and other military projects. The Communist Party leader was looking at displayed combat equipment with evident pleasure and genuine interest. It was common practice for leading aviation designers and military command authorities to participate in such displays. Pavel Sukhoi, wearing his famous hat, is on the left from Leonid Brezhnev. Pavel Sukhoi started his aviation career at the Central Hydroaerodynamic Institute, where he worked under direction of Andrei Tupolev since 1925. With his direct involvement, Pavel Sukhoi designed I-4, the first Soviet all-metal fighter. and I-14, the world's first high-speed monoplane fighter with retractable landing gear. The Sukhoi Design Bureau became independent in 1939. This year, mass production of the BB-1 short-range bomber designed by Sukhoi was started. In 1940, this bomber was named Su-2, and it became the first aircraft which received the famous Su name. Since that time on, combat aviation is inconceivable without Sukhoi aircraft. In the 60s, fighter aircraft designing was a real success for the Sukhoi Design Bureau. These were the aircraft of two types: fighter interceptor and fighter bomber. It was the Su-27 fighter bomber that became the first Soviet variable sweep wing aircraft. Another interesting subject matter in the Design Bureau from the early 60s was creation of the T-4 Sotka aircraft. Creation of this aircraft allowed moving to quite a new level of all the Sukhoi Design Bureau activity, despite the fact that the aircraft was not put into mass production and the project was stopped in the mid-70s. However, this project laid the scientific and technical groundwork that was successfully used later on in creation of the new generation aircraft, including the Su-27. In March 1971, the meeting of Aviation Ministry Scientific and Technical Council took place. At this meeting, 3 design bureaus presented their groundwork on the new advanced fighter. The Yakovlev and Mikoyan projects outwardly looked like the previous aircraft they built. But Sukhoi presented something new. That was a project of the future Su-27. Research work on this aircraft was started in 1969. The originator of the project was Oleg Samylovich, who worked in the Design Bureau Concept Department. By that time, he took part in such projects as the T-4 long-range missile carrier and the Su-24 frontline bomber and the Su-25 attacker. Now, it was a new aircraft turn. The designers had to place the emphasis on the integral layout of the future fighter. The Su-27 also started with Oleg Samylovich. One winter Sunday in 1970, the aircraft layout was created with his hand. On that Sunday, Antonov, Samylovich, and me were working in the office. A day before, on Saturday, Bondarenko was there. All of us wanted to consolidate the achievements made by the team at that time, mainly on Antonov's drawing board. There's a profession dealing with the aircraft pre-designing. This is a work on an aircraft when it is not yet available. Samylovich liked to say, "What is designing? Is it a science or art?" It is both a science and an art. The success of an aircraft design is in fact the status of its designing school. I was lucky to be the person whose drawing board had that aircraft drawn upon it. It's true, but on the other hand, all personnel were behind my back, so to say. Many people from the staff contributed their thoughts to this aircraft and its elements. There is no doubt it was an exciting time. Being young specialists, then we were mainly impressed with the faith they had in our capabilities to work on such overwhelming projects. There were older friends who treated us as their equals, or it might have seemed to us. On the other hand, youth is the best time for everyone. I have the best recollections of that time. After the wind tunnel tests of these models, upon receiving positive results, Oleg Samylovich said, "Vladimir, let's go to Sukhoi." Sukhoi rose from his seat near the table, shook my hand, and gave me a paper where it was written that Vladimir Antonov, designer-engineer of the second category, was awarded the first category with a salary of 185 rubles. The most interesting were the words that Sukhoi said. "Young man, you've done a lot of work, but you have to understand that this is a part of the work being done in the country to conquer this peak, to develop the fourth-generation fighter." So what's the feature of the layout that the designers offered? Let's have a go at this problem. To fly up in the air, an aircraft needs a lift force. A wing plays a key role in this process. There are some specific ways to create a lift force on the wing. These are use of special airfoil section and an increase of an angle of attack. The angle of attack is the angle at which a wing meets an airflow. In these airflow conditions, air pressure under a wing is higher than above it. This pressure difference creates a lift force on the wing. But what about other parts of an aircraft? Do they create a lift force? What about a fuselage? On most aircraft, fuselage creates a minimum lift force. Is it possible to change the situation? It appeared so. The Su-27 designer used airfoil sections to build other structural parts of an aircraft, not only a wing. It would be no exaggeration to say that the whole aircraft became a lift surface. A wing root glove played a large role in creating lift force. But initially, the designers could not see all the advantages of such technical innovation. They thought of a wing root glove as a method to improve aircraft stability at supersonic speed. Only after an enormous amount of wind tunnel tests, the designers realized new advantages of the wing root glove. We had a wonderful guy, Kurichkin, from Roman Irodov's department, who discovered one very interesting effect. If the wing root glove is made pointed, which means that the tip is sharp, a very powerful vortex was induced with this sharp tip. This effect made it possible to increase lift force by at least 50%.